Hello, I'm Kevin. I work on the Exegy team here in Sydney, Australia. I've been working on Graphweaver a lot recently, and we've just released version 2 of Graphweaver. Version 2 contains federation amongst other features. I'm really excited about it, so I wanted to share it with you today. So first off, if you haven't heard of Graphweaver, what Graphweaver lets you do is it lets you take any number of your data sources, be they databases, REST APIs, GraphQL APIs, other things, and join them up into one GraphQL API. This includes authorization, authentication, column level security, row level security, all of these kind of things. But most importantly, you can join all of your data sources together. So let's say in this example, we have a payments database. And we could wrap Graphweaver over the top of that and then get a nice GraphQL API. From that, we would be able to access it on the web, on the mobile, from any of your clients. And this is a very productive way to build. You can always just start with the database, keep iterating on the shape of that database as you're building out your prototypes, move to production, and keep adding custom operations, etc. If you have another data source, in this case, we're going to use a REST API, which is going to contain agents. So an agent would be somebody who owns a payment, and we can bring those together into one Graphweaver instance, which then gives us a GraphQL API over the top of all of that. Now, in addition, let's say that we're at a larger organization. So this is where federation becomes really useful. If you were to join everything under Graphweaver, you would get a lot of very complicated built-in functionality that just comes out of the box, very easy to use, but it would mean that you're all collaborating on one API. So in this case, we have a music team and a payments team. And in the music database is a whole bunch of their information, albums, tracks, customers, etc. Now, if you didn't join these things together, you didn't put them under Graphweaver, or you didn't use GraphQL Federation, then you would have to take all of your clients and connect to all of the different backends. That wouldn't be a very good approach, because you would end up with a whole bunch of different APIs, a whole lot of things talking to a whole lot of things. Every single one of those clients has to know about all of your APIs, has to know where to get each bit of data, how to link it all up. Basically, we're pushing a lot of complexity out to the front end, which is really unproductive, particularly when you know that all of this data is related in a very specific way, and you can do that. So in this example, what we're going to do is we're going to use Graphweaver to join multiple data sources twice, and then we're going to use Federation to join that. So in this example, we have two different teams, the payments team with their data, the music team with their data, and then we're going to use Wundergraph Cosmo to bring it all together into one single API. At that point, all of your clients don't need to know what the source of truth is for everything. They can just talk to this API, not care how it happens. You can still, as a backend developer, see all of the routing of all of this, performance tracking, etc. So this is a really productive way to build APIs in our experience. So I'll just show you what we have in this folder right now. I'll go into the payment subgraph and so on in a minute, but we effectively have an empty directory for our project. So I'm just going to come here and I'm going to ask Graphweaver to init a new project. So we just use the init command line command. This is going to say, what name would you like to give this? We're going to go ahead and call this the music subgraph. And this is, we're going to go and use the SQLite backend. In this case, what I'm using is I'm using this Chinook database. So this is open source, supports all these different database engines, but it is this information. So we have artists, albums, tracks, media types, playlists, genres, reviews, invoices, etc. So the idea with this example is that the music team has these invoices and the payments team is tracking payments against those invoices in a different system. So we're going to go ahead and use that SQLite backend just to make it easy to get started. So it's already created that directory for us. So if we go into this directory, I can now show you what's in here. It's quite empty at the moment. But we just have effectively a scaffold. There's no specific schema files. There's nowhere to actually hook up yet. So now we're going to go ahead and import our data source. So we can use the import command for that. And now it's asking for where the file is. I'm just going to go ahead and double check. It's called this. Great. So now it's inspected that database, and it's found these entities, which are the ones that we expect. It can go ahead and create those files. So now it's gone ahead and scaffolded out our project. So the structure of a Graphweaver project includes a separate area for your backend entities and another area for your schema. The reason for that is because there's often multiple different types of entities. You'll have all these different backends kind of all working together. You want to be able to think about them in that way when you're talking about accessing them. And then you bring it all into one single GraphQL schema in the end. So that's gone ahead and created these. You can see it's quite easy to create these. In a database, you would just do a straight up one-to-many relationship. If you were joining to another data source, you would do that at the schema level. So you would use one of these relationship fields to do that join. You give it the ID, or you give it how to query for that based on the ID, and then it will do that for you in the schema. So that is now ready to go. I'm going to go ahead and install our dependencies. So those, this is just a standard pnpm install. Now I can go ahead and start. When I do, Graphweaver comes with an admin area. So the admin area is a bit like a database editor, but what it'll let you do is it will let you browse your data. It will let you use a GraphQL playground to run arbitrary queries against it. You can also customize all the fields, add custom pages, all of this type of stuff. But we find it a very productive way because you could just model it in the database and just get started. And then you can tweak it into the point where it's a production system. So you don't have to throw away your prototype to go all the way through to production. So we have a functional GraphQL API here. And you can see the relationships between the entities are working and everything. This is all using data loader. If you've ever built a GraphQL API from scratch, you know kind of how much you just got for free out of that. And if you haven't, then just be glad that you haven't had to learn all about that. So great. So we have a functional backend now and a functional admin area. So I'm going to go ahead and enable this for federation. To do that, all I need to do is tell Graphweaver that we are going to operate in a federation world. So federation subgraph name, I'm just going to call it music. So why do we need to give this a subgraph name? It's because Graphweaver has a number of types that are sort of singleton types, things like media. Now, if you create media as an entity and you give it the name media in a federation context, then the router, the federation system, has to know that it can get that data the same from everywhere. And in our world, you would get different data sets. You would have one Graphweaver project that calls itself, that has an entity called media, and another one that has an entity called media, and they would return different data. So those will clash. So when you say there's a federation subgraph name of music, all of these singleton types will get namespaced correctly. The other thing it will do is it will add all of the federation directives to our schema. So I'll go ahead and just start this again. And now our admin area will still work as per normal. But when I go to the playground, if I look in the actual schema here, you will see there's an underscore service, which is for federation, and underscore entity. All of these federation entities have been added, and things that needed to be namespaced now are. So that's our federation is now enabled on our music subgraph. So I've gone ahead and created our payment subgraph already, just because it's a little bit more complicated. So I'll walk you through that now. So in the payment subgraph, we have a Postgres database, which has a payment in it. This again was generated for me by Graphweaver doing Graphweaver init after I created the database table. So that was pretty quick. I've also created a trace entity just to demonstrate the performance tracing functionality that Graphweaver gives us. There's also this REST folder. Now, what the REST API is in this case is we're using this swappy.info API. This is the Star Wars API. It has all the characters, films. So just as an example of how we could use a REST database, the people from the Star Wars universe are going to be our debt collection agents that are assigned to payments in our example. So what I've done is I've given it the fields that exist on those responses. And I have also in the schema, we have our invoices and payments. So payments in this case are in our database. So this is just the field that the table that exists inside Postgres. And I've just given it the fields, and then we've given it this entity. Now, invoices are a little bit interesting. What's happening here is we have basically a linking entity. So we need to be able to tell the federation router that in this payment subgraph, we're going to reference invoices with their IDs because payments know about the invoice ID here. Now you'll see in the actual schema, it's just a number. As far as the GraphQL schema is concerned, it's just an ID field. It has no idea what that relationship is. So we have to go ahead and tell it about that relationship by telling it there's a relationship to invoice, and the invoice has an invoice ID. So resolvable via federation is going to tell the router, it's going to add a directive to the GraphQL schema so that the router won't try to come to us to resolve invoices in the payment subgraph because we can't get the invoice data. We know the IDs from our payments, but we don't actually have the invoices themselves. So most of this project actually came from a similar process to the one I just ran through on the music subgraph. The rest of it was just added in by hand. But as you can see, it's not very complicated at all to be able to do that. So we now have two graphs they're running on different ports. That's the only other change I made here is I made sure to change the port so it won't clash with this one just because I'm running it on my laptop all at the same time. So now I'll go ahead and show you how to bring these together. So in our supergraph folder, what we have is this compose.yaml file. Now I've taken the most simple version of this. You can obviously configure a lot more heavily in here, but we have two subgraphs. We have one that's called music and another that is called payments. We've just given it the URL to go query to inspect. And we've also downloaded the router from the Wundergraph Cosmo repository, which is here. So if you come here and you go to the releases, you want to find the most recent release for the router and download that release. You'll also want to install the Wundergraph command line tool. So when I run wgc router compose and I give it the input file of compose.yaml and the output file of config.json, what it has done there, and you can actually see it in the logs of the various services, is it's gone off and it's interrogated those services to figure out what are all of the entities and what is all the schema that exists for these APIs. And it's bringing it all into this config.json file, which it uses to be able to route. So now if I run the router, it's listening. It is listening here. All right. So we have Cosmo running. Now in this schema, we have all of the entities from the music subgraph. We also have all of the entities from the payments subgraph. And we can run queries across both of those. So if we grab the payment, we can get the invoice, and then we can get information off of the invoice. We can also get the amount on the payment, and we can get the agent on the payment, which is called owner, and name. So when I run this query, what's happening here is I'll go ahead and show the trace view just because it's a little bit easier to tell what's happening. It has gone first, let me zoom in. Great. So it has gone to first our payments subgraph to get the payments. It's figured out in the response that there are invoices with certain IDs, and then it has gone over to the invoice subgraph, and it has gotten those invoices. Inside Graphweaver, we've actually joined the REST API in here, which is how we got the Star Wars API people in. So Federation is a really powerful way to join up your APIs, particularly when you can't collaborate on a single code base together, or you need to ship to different deadlines, or you need to be individually accountable for what you're building. And Graphweaver is a great way to build your subgraph so that you don't have to build it all completely from scratch. There's very little code actually needed. You're just modeling the shape of your data and telling Graphweaver how to get it, and it uses data loader, and it gives you this admin area that's all ready to go. So let me just dig a little bit more into that payments subgraph, which I've already kind of walked you through a little bit, and just show you what's happening in there. So inside this payment subgraph, we have the REST API. So these are all of our Star Wars characters. And we have our payment entity. And you can see that we have some sample data in here and we have owners on each. It's able to join over to that REST API just fine. In addition, I've enabled tracing on this one. So inside Graphweaver, we are able to use OpenTelemetry to trace our operations. So you can plug that into your OpenTelemetry server if you already have one. But equally, you can use our internal collector, and the internal collector will let you do this. So inside the Graphweaver admin area, you can see all of the operations, exactly what happened to service that operation, and exactly how long it took, what the query was, what all of the arguments were, etc. So this is something we recommend sending off to a different database than your production database if you're going to use it internally. But equally, it can go to a cloud service. It can go wherever it wants to go. So I just wanted to give you a quick demo of the power that you could have if you use Graphweaver to build your subgraph and you use Cosmo to federate. You're good to go. You can iterate on this. You can add entities. All you need to do to then bring them back into Wundergraph is compose again and make sure that you don't get an error. And then you can ship your APIs using all of the awesome Cosmo functionality. So that's the feature that I'm most excited about in our Graphweaver 2.0 release. Just coming back to this to kind of recap, when should you Graphweave? When should you use Graphweaver to join data sources? When you are willing to coordinate releases together for everybody that owns all of the data sources that you're working with. So those could be dynamic CRM instances, they could be databases, REST APIs, whatever. As long as you're willing to coordinate releases together with those other teams, you're good to go. You want to be able to share a code base without trouble. So if your teams are going to step on each other's toes, if they're all working out of the same repository, or, you know, I'm under pressure, I'm on a deadline, and then they break your stuff, not great. That's when you'd want to move towards more of a federation approach. And also, if you need more functionality in the joining of data sources, because Graphweaver directly integrates with all of your data sources and then creates that GraphQL API, you can get a little bit more functionality. So cross data source filtering, for example, is something we can do inside Graphweaver because we actually know about all of the data sources very intimately. And you need to be able to be held accountable as a unit together with the people that you're working with. But if you can comply with all of those things, then you can get more power at the technical level. So when you should federate is when you are separate teams releasing on different schedules. When sharing code between you is going to mean that you're breaking each other's stuff all the time and you're fighting more than you're working together. And if you don't necessarily require all of the crazy advanced functionality that Graphweaver gives you, then federation is a more loosely coupled way to collaborate and still build one API. So the source code for this example that I've just gone through is here on this GitHub link. And if you want to run through it yourself, just see exactly what's in there, exactly what's been built, how much work that would take. You can see, but most of it, as you can tell, is generated, and the rest is able to be very quickly modeled by just using some decorators on your entities. So that's Graphweaver version 2 and our new federation support. I've been Kevin, and I really look forward to talking to you more about what we're building in Graphweaver in the future. Thanks for your time.